So in this video we are going to learn how to drive trigonometric identities with much easier without having to calculate by just using a simple hexagon. Okay, me I call it the super hexagon. An hexagon is just a simple angle with 6 sides, just a simple shape, in short, just a simple shape with 6 sides. So this is an hexagon with 6 sides. So 1, 2, 3, 4, 5, 6. So this is how you drive the identities. All you need to know is one formula, which is the first formula. This is the formula which you need to know. Tan is equals to sine over cos. So tan is equals to sine divided by cos. Then at the middle of the shape, at the middle of the hexagon, you write a 1. After that, you connect the opposite vertices with a line. So you connect the opposite vertices, like this one is opposite to this one here. This one is opposite to this one here, and this one is opposite to this one here. So you take this first identity which you have mastered, tan. You write tan at the first vertex here, tan. After that, which one is on top? Sine. Then divide by cos. You write cos here. After that, you see that we are still remaining with the cot, cosec, and secant. So here you write cot at this bit. Then here you write cosec. After that, you see that you are remaining with the secant. So here you write sec. Once you have written this, you can now proceed to driving the trigonometric functions. This is what you do. To drive this first identity, you saw that we had tan. This is tan. So we just wrote here tan theta is equals to, which one follows tan? Is it, if you go in clockwise, like this. So you see that tan theta is equals to sine theta over sine theta over cos theta. So to drive for sine theta, you just write here sine theta is equals to, which one follows sine theta clockwise? Is cos theta over cot theta. To drive for cos theta, you just write cos theta is equals to cot theta over cosec theta. To drive for cosec theta, you just write cosec theta is equals to sec theta over tan theta. To drive for sec theta, you just write sec theta is equals to tan theta over sine theta. Then if you want to drive for cot, you just write cot theta is equals to cosec theta over sec theta. Well, my friends, it doesn't end here. I shall also show you how to drive other trigonometric identities using the same super hexagon. Well, my friends, it's the same super hexagon. You connect the vertices here with a line, and the one at the middle, remember, you start with tan, sine, cos, cot, cosec, then sec. Oh, if you're having trouble to master on how to place these 6 functions in the vertices, just know that if you divide the shape at the middle, the functions you can see are being on the right hand side. So that, remember, at first we are going in the clockwise direction. What if you make a mistake and go in the anti-clockwise direction? This is the anti-clockwise direction. Well, this super hexagon does not try. Still, you still get the correct functions. You can start with tan theta is equals to, which one follows tan theta is sec theta over cosec theta. After that, you can also derive for sec theta is equals to cosec theta over cot theta. After that, you can also derive for cosec. Cosec theta is equals to cot theta over cos theta. You can also derive for cot. Cotangent cot theta is equals to cos theta over sin theta. You can also derive for cos. Cos theta is equals to sin theta over tan theta. Well, the pattern goes on. You can also derive for sine. Again, you come back to tan, just like that. That is if you go the anti-clockwise manner. Well, my super hexagon does not end here. Well, I'll show you other patterns. Well, my students, I guess at this time you are wondering why are we writing a 1 at the middle if we are not even using it. Well, let's use it a bit. So if we have a 1 at the middle here, and then the vertices are connected with lines like this, well, just know that if you multiply functions in the opposite vertices, the answer is equals to 1. So let's say if you multiply sine multiplied by cosec, if you say sine theta multiplied by cosec theta is equals to, the answer is 1 at the middle. Also, when you multiply cos theta multiplied by, it's in opposite with secant theta, sec theta is equals to, the answer is also 1. When you also multiply tan theta multiplied by cot theta, the answer is also equal to 1. This super hexagon, you can also use it to drive other identities. Well, just know that the product of 3 continuous functions, the answer is what is on the middle. So if you are going clockwise like this, the product of 3 continuous functions. So if we take this one, tan multiplied by cos, the answer is what's on the middle. You do this, in short, you do this. Again, here if you want, you do this, and here you do this. So if you take tan multiplied by cos, tan multiplied by cos, tan theta multiplied by cos theta, the answer is what's on the middle, sin theta. Well, what if you take sin theta multiplied by cot theta? Sin theta multiplied by cot theta, the answer is cos theta. Well, if you multiply cosec theta multiplied by tan theta, the answer is sec theta. If you get sin theta multiplied by sec theta, sin theta multiplied by sec theta, the answer is tan theta. You can go on, just you multiply this and this, you get this, this and this, you get this, this and that, you get that. So the answer, when you multiply 3 continuous functions, the product is the answer. The product of 3 continuous functions, what's on the middle is the answer. So if you do tan multiplied by cos, the answer is sine. If you get cos multiplied by cosec, the answer is cot. Remember, this is a super hexagon and you are still going. Well, here you write tan as wise, sine, cos, cot, cosec, then here secant. After that, you write a 1 at the middle like this, and then you connect the opposite vertices like this. Well, let's get to use the 1 at the middle again. So here you see functions in the opposite vertices. So if you want to drive for sine, here you just write sine theta is equals to, you get the 1 at the middle, 1 over, what's in the opposite? What's in the opposite? What's the opposite function for sine in this instance? It's cosec theta. So sine theta, its identity is also 1 over cosec theta. Sine theta is equivalent to 1 over cosec theta. You can also come here, cos theta is equals to 1 over sec theta. Then you can also drive for tan theta. Tan theta is equals to, just write the 1 there, 1 divided by, tan is the opposite with the cotangent, cot theta. You can also drive for cosec theta. Cosec theta is equals to 1 divided by sine theta. Well, for sec theta is equals to 1 divided by cos theta. Remember, this one is at the middle, and this super hexagon has also helped us again to drive how many identities? 1, 2, 3, 4, 5. 5 other more identities, but you can drive 6 if you just follow this pattern. You just take, for instance, tan theta is equals to 1 divided by cot theta. Sin theta is equals to 1 divided by cosec theta, just the way I was doing. Well, let's now drive the remaining of the identities. Well, my friends, do you remember complementary angles in secondary? If you don't worry, we are going to do it with you. This is what you do. After writing the super hexagon like this, you write the arrows like this. Okay, I guess you have seen. So this is how we are going to use the complementary angle, the row of complementary angles. So here, if you want to drive for sine theta, the identity for sine theta, so just write here sine theta is equals to cos, open bracket, 90 degrees minus theta. This is the row of complementary angles. This is the row of complementary angles we are applying. So if you are driving for sine theta, here sine theta is equals to, so sine theta is in the opposite direction, or the arrow is approaching cos. So we write cos, open bracket, 90 degrees minus theta. This is also another identity. You come here, you also drive for tan. Tan theta is equals to cot. You apply the row of complementary angles. Cot, open bracket, 90 degrees minus theta. You also come here, you write sec theta is equals to cosec. Cosec, open bracket, 90 degrees minus theta. So this, you can use this row of complementary angles to drive identities. What if it was going in this direction like this? Well, the row of complementary angles is the same. As you know, mathematics does not lie. So here, just write cos theta is equals to sine, open bracket, 90 degrees minus theta. If it was for cot, you just write cot theta is equals to tan, open bracket, 90 degrees minus theta. If it was for cosec, you just write cosec theta is equals to sec, open bracket, 90 degrees minus theta. Well, we are still not done. Well, so here, this is our super hexagon again. And if you partition it like this, you see that it has got 6 triangles. So this is what you do. You just you skip 1. So here you select this triangle, and here you select this triangle and this triangle. After that, you draw an arrow inside. An arrow must go in the clockwise direction, like this. An arrow must go in the clockwise direction, like this. Then even here in the clockwise direction, and even here in the clockwise direction. If you see, the arrow has got a tail and a head, a tail and a head, a tail and a head, like that. That's how you draw it. After that, then you start driving the identities. The identities which I'm going to drive here are very common. Even in grade 7 pupils, they know how to drive this. So this is what you do. You just add this function plus this function. Then the answer, so it will be like this. So the arrow is what directing us. It's like this. So you start from here. The tail, where is it starting from? It's here, sine. So you write sine squared plus, you add, plus cos squared is equals to, where is the head? 1. Remember, it's 1 at the middle. Is equals to 1. Well, this identity is very common, and you can actually use this identity to drive the rest of the identities. For example, you can start by dividing, divide by sign, divide by that sign. You can drive a lot of identities by just using these identities. Now, if you don't want to use that, don't want to struggle like that, that's why we bring the super hexagon in, which you can help you to come up with all other identities. After that, you come here. You see, where is the tail starting from? Here there is 1 here. You write 1. We could have written 1 squared. Now 1 squared is the same as 1 plus. Where is it going? Here there is cot. Write cot squared is equals to, where is the head? Where it has ended? See, on cosec. So here cosec squared. So 1 plus cot squared, the answer is equals to cosec squared. When you come here, it's starting from here where we have tan. So write tan squared. I'm forgetting the theta here, but it's not important. So tan squared theta plus, here, if you see, we have 1 here, plus 1 is equals to sec squared theta. Okay, you see. Well, what if you wrote the arrows in the opposite direction? Let me show you. What if the arrow, you made the mistake, right? The arrow was written in the anti-clockwise direction, like this. Oh, I've made a mistake. Here, there is not supposed to be an arrow. An arrow is supposed to be here instead. You are supposed to skip 1 box, because there are 6 boxes. You just select this one here. You just select this box here. You also select this one here and this one here. After that, now how do you drive the identities? How do you drive the identities? Well, see, where is the tail starting from? The tail is here where there is 1. Remember, the tail is here. So you just write 1. So here you write 1, like I said, minus. If you see, it's going this side. And here we have cos function. So you write cos squared theta is equal to, where is the head? Here where there is sine, is equals to sine squared theta. This is also a very common identity. After that, you come here. Where are we starting from? We have cosec squared theta. You subtract minus cot squared theta is equal to, if you see here, it's bringing us where there is 1, is equal to 1. The last one here, we are starting there where there is secant. Sec squared theta minus, we have 1 at the middle here, 1 is equal to tan squared theta. Well, my friends, this is how the super hexagon has helped us to drive as many formulas as I can't remember. Well, it's okay to be genius. Study smart, study less. If you have liked this video, share with your friends and other students who also like to study with much ease without putting much effort. You can also click the subscription button and also like the video and also ring the notification bell so that you don't miss out on other contents like this. Thank you.